board. Okay, so midterm 1, we're going over things from Friday and starting with number 3. So we're rounding 3714.3714. No, wrong problem, I'm sorry. We are dividing 176 divided by 24.3, and we're told to round both numbers to the nearest tens place. So tens, we want those as zeros. So 176, the 6 is 5 or more, so that will become 180. And then 24, the 4 is not 5 or more, so we go down, and that will become 20. 180 divided by 20 is about 9. Okay, number 4. So what she has is 5 of 1/6 of a skein of yarn. Is it skein or skein? How do I say that? Skein? Okay, skein. And each stripe she wants requires 1/60th. So how many stripes does she get for just one of her partial skeins? How many times can you get 1/60th from 1/6? 10. So there's 10 stripes. So she can get 10 for each partial skein. She has 5 of those partial skeins. So she can get 50 stripes total. If you have more questions on this, wait a bit, because once we do fraction division, then you can do it that way too. This was from when we had those pieces of paper and we were ripping them up over here. So to mentally understand division. Okay, that was 3 and 4. Anyone have questions on 5 through 10? Yes.
8.
8, 9, 8 and 9. Okay, 8. So we want to reduce 9 over 39. Okay, what's in common?
3.
3. 3 is a common factor. Are we done? Can we keep going? We're done. If you weren't sure if 3 went into 39, remember that divisibility trick. Add up the 2 digits, 3 and 9 makes 12. Does 3 go into 12? Yes, 3 will go in. Okay, next one. Oops, not that. We wanted to clear out that decimal You could think of it as a times 10, or you could think of it as a scoot to the right. Whichever way it makes sense in your brain to think about it. To be fair, if we're doing it on the top, we have to do it on the bottom also.
So you always have to move the decimal point on one side to the right.
You have to, whatever it takes to get rid of the decimal. If this was a 6.65, I'd have to do 2 scoots, right? As many as you need to get all the decimals out of your fraction. But in this case, 1 is enough. Mm-hmm. Okay, now I can start reducing it. There was that trick of if you just look at the 10s and 1s, you could test for 4s. Right?
Okay.
So 56, 4 goes into 56. So 4 is going to work. Okay, I can try that trick again. Does 4 go into 14? No. So 2 will work because they're both even, but 4 isn't going to work anymore.
Is there a faster way to reduce it?
Is there a faster way? Not unless you're just doing big numbers or cheating with your calculator, A, B over C button. So. Okay, what next? I'm done with the evens. If I add up the digits, 7 and 2 is 9. 5 and 5 is 10, 8, 18. So 3 goes into both, 9 goes into both. That will be even faster. So let's do 9 goes into both. As long as I'm using my calculator to do the division, I don't mind dividing by a bigger number. And then 23 is prime, so we have to be done.
And the next one, you just divide 9 divided by 1, 44.
Yeah, top divided by bottom.
Oh, yeah. Okay.
Okay, anything on 11 through 15?
Struggle.
I'm not good at word problems. I did 11 right.
Okay, I don't want to take the time to do it both ways. So since Kishan asked, do you like the money divided by amount or do you like the amount divided by money method?
Whatever you prefer. So just
Money divided, okay. So whichever way you pick, you have to do it the same both times.
Oh.
So 16. I should say rounded. So if we're doing the money divided by amount method, do we want the bigger or the smaller number for the better buy? The smaller, right? We want to spend as little as possible for 1 ounce of this thing. Yes. 14, let's see, anyone want 12 or 13 before we do
12.
14? 12? Okay, 12, we'll get to a better way in a moment, or not in a moment, later on. But a lot of people like these with a unit rate. So if we have 84 yards and divide it by 0.91 minutes, or did I say 0.91? 9.1. So that's about 9.2 yards per minute. We're finding the speed that this wonder snail is going, right? So if every minute it goes 9.2 yards.
Sometimes that might be just.
Yes.
Okay, that's.
So then in 57 minutes,
First you divide the mean time.
and I'm just going to round to the nearest yard because it makes sense. Okay. Okay, 14.
So you just move it over. You just count the zeros.
Yeah. So we're going to multiply by 100,000. So that has 5 zeros.
So when you multiply, you move to the right.
So we're going to move to the right because we're multiplying by something that's big. So 1, 2, 3, and then 2 more. So we'll need 2 zeros there.
So, my question is, what's the rule of that? Like, is it the multiply to the right and then divide this to the left? Is there some?
There were 4 different cases.
Okay.
That the first 2 cases were if this number is bigger than 1,
Okay.
right? So something like 100 or 1,000 or million, whatever. So then multiply was right and divide was left. The second situation was when this was not a power of 10, but a power of 1/10. So 0.1, 0.01, 0.001. And for those, then it was the opposite direction. Multiplying makes things smaller. If I have a 10th or 100th of an amount, I have just a bit of it. And if I divide, it makes it bigger. Remember the backwards of backwards is forward that we did?
Oh, yeah.
Okay, 15 to 20. 17. Our next one. Okay, so our summary thing was RIPLOP, acronym for right into percent, left out of percent. Are we going into or out of percent?
We're going out of.
Out of percent. So we're going left. So 0.79243. I know we have to do 20. Anyone want 18 or 19? 19. So
Top.
18 is the other direction, right?
Yeah, so it's just like,
So 19, RIPLOP isn't what we want,
no, it's,
at least not immediately. If we want to make this number a percent, then the easiest thing to do is first make it a decimal. And then go
I was.
from decimal to percent.
Okay.
Right.
Oh, because there's more steps, that's what I was forgetting. I was just.
And this test is so polite. On number 10, you already did fraction to decimal for this, so you didn't even have to hit keys on your calculator another time.
Can we do the 20?
Yes, 20, of course we do.
I was just forgetting.
It's the annoying special case that never comes up in real life, but I have to teach you anyway.
And it was-
So I want to take this thing out of percent format, but I want to keep it as a fraction. So riplop isn't going to work as the quick thing to do, because then I'd have to go back into fraction at the end, blah, blah, blah. Whenever I see a mixed number, my first instinct is to get rid of that. So 8 times 5,
it's 40.
40, plus 4 more is 44. I'm still in percent.
Okay.
If I want to take this percent and replace it with something else, then 1 over 100 is the quick thing in this
Okay.
case.
Is it always gonna be 1 over 100?
For this special case of taking a fraction that's already in percent format and changing it to a fraction that's not in percent format, then yes,
Okay.
because that's the nice thing to do.
Oh.
Okay, I'm not quite done. Let's divide by 4. If I have $1, I have 4 quarters. So if I have $5, I have 5 times 4 is 20 quarters.
Oh, so we just reduce it after that.
No, I'm sorry, I'm thinking wrong. If I have 100 divided by 4 is 25. So I have 5 25s, so 125. There we go. I am being too clever for myself. Okay, there we go.
And then you basically, the last part, you just reduce.
Yeah, that's whenever you have a fraction, you're supposed to reduce. So that's the rule.
All right.
21 to 25. Anyone want those?
Yeah.
24. 24.
Okay, so the milliliters, 21. So you just would use that like KU,
No, 21 is the trick question. A cubic centimeter is a milliliter. So you don't do anything to the number. You just say it's the same thing.
Oh, okay. I didn't
It
know.
is testing
So
your
milliliter and
definition.
cubic centimeter is the same thing.
Yep.
Okay.
They're 2 words for the same amount.
Okay.
Okay.
22.
Okay, so 101 centimeters is how many feet? And we are told that there's 3.48 centimeters in 1 foot. 30. So am I going from a smaller unit to a bigger unit or a bigger unit to a smaller unit? Smaller. Centimeters
Yeah,
are
I'd have to
smaller.
say big units is
Oh,
smaller.
yeah.
So smaller to bigger. And is that multiply or divide? Oh,
Can you look at that? Isn't it, you can look at that KU and then just.
No, that's only if you're staying in
Oh,
SI
I
units.
understand.
So here we're mixing up. We have some SI, some metric, and then we also have feet, which messes us up. So 101
Okay.
divided by 30.48 is about,
So, smaller to bigger, you divide. And then bigger to smaller, you
multiply. And if you can't remember that, think about a ruler that's a foot long. If you have 12 inches going to a foot, the inches are smaller. You're going to the feet, which is bigger, and your number is getting smaller, so you're dividing. Whereas if you're taking a 1 foot ruler and shattering it into different 12 inches, that's the bigger foot going to the little inches, so you multiply to get more.
Okay. So,
And if you can't remember that well, there will be a trick we get to make it automated, and it tells you whether to multiply or divide. We're just not there yet. Yes.
So will we be going through this converting like our American system to metric and vice versa? Will we be going through how to do that?
Yes, well, if this way doesn't make you happy, the smaller to bigger or bigger to smaller rule, then there's another way we will learn later. Okay, 25. Okay, now finally we get to do the scoots you've been wanting.
okay.
So the killer hobos dance under dazzling crystal mobiles, ... micro. We're starting
What is it? Killer
dazzling crystal mobiles. You could make up your own, but that's the one I use. So where are we starting?
We are starting the meters.
The units. The units is meters, the plane units. And we're going to kilo. So 1, 2, 3 to that direction. 1, 2, 3 in that direction.
Okay, so it's really that's pretty
Yeah. For this first bunch of problems, right, your biggest danger is making them harder than they are.
Yes.
On the real final, you'll have about 3 minutes per problem. And a few of these might take you 3 minutes, but a lot of them, if you remember which tool to use in your toolbox, they're really quick. So the big danger is trying to use the wrong tool, like trying to do decimal scoots with something that is moving into standard units, or just forgetting what tool to use.
Well, with the percent format, I was doing like the thing from the section before, I'm not adding that second step to get it to the percentage, so.
Yeah. So the practice tests are your friend. If we are done with the shape-shifting topics, I don't know if we actually are at this moment, but soon we will be, then your job is to take more random midterm ones, go to the practice tests,
That's what you just sent out.
and
Right.
go here. The email I sent is just this particular one,
Okay.
right? So that we could talk about it today, or you could look at it over the weekend if you're impatient. But every time we reload this page, you get a different one with different numbers. So keep doing this. Otherwise, you'll get rusty. And no matter how ready you feel today, then by the time we get to week 10, some of these obscure things that you're not going to keep doing, they will have fled your brain and gone away. Right? So keep doing these, not necessarily every week, but maybe every other week, sit down and do one and keep yourself from getting rusty. Otherwise, you'll have more work on week 10 when everyone is wanting you to do papers and cramming and studies and so on. So it's better to keep it fresh than it is to forget it and have to relearn it. Okay, other homework things from this first chapter. Any of these topics, something that you want me to do more problems on?
Fraction format.
Fraction format, what about it?
Number 9.
The turn-in homework? Sure. Turn-in homework. Number 9, that's just a division. The big number divided by the little one. So,
I had a problem with 8.
with 8.
Yeah. My parents were a little confused with that too, and they were trying to help me with it.
Okay, so the tricky thing about 8 is that we're not doing anything with the numbers but writing them, right? There's no division or anything happening. It's just saying, make this a ratio.
Oh, so you don't want to
So-
solve for anything?
It says, what's the ratio of distance to height? So which one comes first? The distance, that's what it says. So the distance it leans is the 13. So we have to write the 13 first, and then the other number second. The height number second. It could have asked us, what is the ratio of the height to the distance it leans? And then it would be the other way around. There's nothing inherently right or wrong about one flip versus the other. We just have to do whatever it tells us, which in this case is putting the distance first. Another question? No?
Oh.
Thank you.
So let's wait on that. Thank you.
Okay, any questions on the percent ones while we're here?
So then I'll simplify that. And this one?
9.
9. After we change 2/3 into percent format, do its digits repeat endlessly. So the 2/3 as a decimal, you were supposed to memorize. What was the decimal format for 2/3? In this direction, you can just use your calculator. So you could do 2 divided by 3. And you'll get 6s forever.
It was just my 0.
It was the other direction that helps to memorize it. If you see a bunch of 0.66666, you should know that's 2/3. So I want to make it a percent format. Which of my ways to make things percents do I do?
Move the decimal 2 to the right.
Right, we're doing riplop to the right into percent. And then all these things keep going. You could write it with a bar if you wanted. So for this, yes, they repeat endlessly. You don't stop that just because you've scooted.
I have a question. On this little top quiz, is it gonna be open notes or no?
Oh, I don't know. I haven't even figured out what I'm
You
doing.
don't know, it's a yes or no.
So
I mean,
we can this week. This week, at least, it can be open notes. I'm not going to commit to forever.
what about on the final?
The final is definitely not open notes. That's just division policy. I don't have any
Will we
choice.
even have scrap paper?
You should have scrap paper because the problems will be printed on something as dense as this. You won't have room to write your steps nicely.
We'll be able to use our calculator.
On the final, yes. That's why we're peeling off the no calculator problem separate.
Last term, I said no.
Okay, any other homework questions before new stuff? Yes.
I was a little confused with number 6 because in which you're right, 25 and 3/8% as a fraction. Thing is, it's already a fraction.
But it's a fraction in percent format. So just like this one, we have to take that percent symbol and replace it with something that means the same thing.
Oh.
So mimic that one.
Can we do 10?
Can we do 10? 10 is just the same as 6 in the one I just showed you. So
So on one, it would be 3 places instead of a left.
yes, 3 and left.
And then, right, the next one, is it gonna be to the left as well, or right?
So this one was something that's tiny, right? 100.
Oh, yeah,
So it's going to get smaller. So you are directed to the left.
okay.
And then how many scoots? 2. Okay, actually I can be done with that. So let's talk about our new thing. Just as a heads up, I found this morning one section of this that I didn't like how I had worded it. So I'm going to reword it some, and I might even be a masochist and put in some more example problems, which means everything after that I have to renumber. So if you've printed this out already at home, then I apologize for messing up your numbering. And if you're thinking of printing this out, wait till I send you the email that it's safe to spend all that paper. So otherwise we'll get towards the end and your numbering won't match mine anymore. So. Okay, so we finished with everything with one number. So now we're moving on to how to put things together. I'm gonna make this a little bigger actually. So here are mathematical expressions. One number is an expression as well as being a number. Or it's all of these other things where we're just having lots of stuff strung together with arithmetic. It has one or more values. They could be a variable, like an x or a y or a z, or it could just be numbers. And we have to link them with valid arithmetic. So first, if we work out the arithmetic correct, then we'll simplify this to be just one number. Second, there's no equal signs if it's officially what's called an expression. But we are going to pretend that if you put a y equals on front, it's the same kind of thing. Because in this class, it doesn't really matter if you have 50 minus 2 times 10, or we say y equals 50 minus 2 times 10. You do it the same way. It's just how we're labeling it at the end. So we're allowed to put a y equals on front, because the tools are just ignore it and do stuff, right? So we're a little bit sloppy there. And lastly, there are invalid arithmetic things. They don't divide by 0. So just because you write stuff on the paper doesn't mean you can always simplify it and turn it into a number. But I'm not going to trick you and say divide by 0 and then oh, ha, ha. So anyway. So as always, you can see if there's hidden answers. There aren't as many here because I've been busy and haven't put them in. And Control F is your friend to find things. Whenever we get to a brown subheading, this tells you where in the textbook to go. And like that. Okay, my job, as always, is to try and explain things clearly. Some of you who don't like pictures will get annoyed at me today, but that's okay. Others of you will think this is nice. But the textbook has a way to explain it. I'm sure you've seen this before in some math class. If you like that explanation better than mine, great. Tell me, share it with everyone. But I'm trying to give you another way to think about things just in case it helps kind of fill in the gaps. So fraction multiplication. I have a picture and I want to show multiplying 1/3 by 1/2. So I have my third, and I want to multiply it by a half. So the best thing to do is just pretend this is like a cake and I'm slicing through the middle. And I get half of my cake. Now only this piece is double shaded. The rest I'm just, like, this is an empty part of the cake pan. There's only a third of it left, and now I have to share that last piece with a sibling. So I get half of that third. Let's look at another picture. Whoops, what happened? Oh, I forgot to ask, what are the numerators counting? So when I do 1 times 1, 1 times 1 is 1. In this case, it's how many pieces I had. 1 out of 3. In this case, it's how many pieces I have. It's 1 out of 2. What is the 3 and the 2 measuring?
Wait, what? Sorry.
What are the 3 and the 2 measuring here? It is a 6. I do mind if it's a 6.
What did you just say?
What's the 3 about? If you didn't understand fractions, if you have a
That's how many
third
boxes
here.
there are? One out of 3 are shaded.
Yeah, it's kind of how small my pieces are, right? So I had a piece there's 3 in the whole, and now I'm saying that one I have to split into 2.
Oh.
So these are like about size, and these are about counting how many.
You kind of
Okay.
lost me with the half
So
part.
what,
That's okay.
It kind of, I feel like
so
I got the answer just without the half part.
Yes, I am starting too easy on purpose. So now let's have 2/3. And I want to multiply that by 3/4. What should I do?
You can multiply straight across.
Yeah, so let's make quarters. And then I want to highlight 3 of them. So now the place that overlaps is, there's my overlap, right? So I started with 2/3 of my cake pan full. This part was eaten already. And I'm gonna share it with my toddler, so I get 3/4 of it. 1, 2, 3. And my toddler, who's smaller than me, gets 1/4. So again, the numerators are sort of counting how many pieces we're talking about. And 2 here for green, 3 here for pink. And then the denominators are sort of how big these pieces are. If this isn't helping you, just kind of tune out for a minute. Okay. The gist of this is that we can multiply fractions by multiplying the numerators and multiplying the denominators separately. I should actually finish up on that previous slide and say 2 times 3 is 6, 3 times 4 is 12. So what we have is 6, 1, 2, 3, 4, 5, 6 out of the 12 pieces.
Or 1/2.
You can
Yes, we could
that.
reduce it to 1/2.
would
If
you-
I physically cut out these 2 pieces and stuck them here in the cake pan, then the top half would be shaded.
Okay. Oh, it would just be
So, okay, let's do another one. So 2/3 times 7/5. 2 times 7 is 14 on top. 3 times 5 is 15 on the bottom. And we're done. Like always, if it's a fraction answer, if we can reduce it, we have to. So 5/7 times 1/10. We're going to get 5 times 1 is 5. 7 times 10 is 70. And I know somebody wants to say something, but wait just a moment. We will get there. Oh, oops. Okay, so 5 times 10 is 50. 5 times 4 is 20 more, so 14. If I did that right. Okay, hopefully everyone is happy now, except if there's a short pick here, you're itching to tell me, but we will get there. But yes, multiplying fractions you've done before, multiply across the top, multiply across the bottom. And if it doesn't make sense why that rule is, then go back and stare at my pictures more tonight, and then you can understand. And if it doesn't make sense or you don't care, then that's okay, just follow the rule. Okay, ready to go on? Yep. So in this case, we had to do a divided by 5, top and bottom. And that worked, but we like being lazy. So canceling is reducing early. Let's do the 5/7 times 1/10 in 2 ways. And I want it nice and big so you can see well. What we did before was great. There's nothing wrong with this. But there's a 70 on the board. And we can avoid having that large number on our paper. We can say, I know I will need to divide by 5 top and bottom just by looking at this much. Because 10 is 5 times 2. So when I multiply, there will be a 5 in the factors of this stuff here in the denominators. So I can reduce early. I can say, let's divide this 5 by 5, and let's divide this 10 by 5. And then when I multiply, 1 times 1 is 1, 7 times 2 is 14, and there's no 70 on the paper on the bottom part.
Nice.
So the name for this is canceling. We're canceling out the 5.
I remember this.
So is this in part of percents? Or
No, this is just fractions. There's no percents at all. Yeah, we're just multiplying fractions. So canceling is nice. I don't have to see bigger numbers on my page. It's the same math. I still have to multiply across top and bottom. I still have to divide by 5, top and bottom somewhere. But I can do it in the order that makes it nice for me. Let's do more of these. So 3/5 times 1/10. And also 6/11 and 2/3. So try both of those, and I'll do them in a moment. See if you, your neighbor, agree on things before I spoil the answer. Actually, I'll do attendance real quick while you're working. So Abdullah is here. Cabello is gone. Arjna is gone. Alexi is here. Amanda is not here. Avery. Aya is here. Cade. Dan Rentier is here, and Dan Nolan is here. David Welshman. Yeah. Israel. Jaron. No Jaron. Carl. No Carl. Okay, Kashan is here. KJ's here. Matthew. Michelle. No Michelle. Okay.
Over here.
Oh, there you are. Yes. Mickey is here. Myrna is here. Riley. Ryan. Samantha isn't. Sarah. There you are. Sheila. Sonia. Is here. Sheila is here. Tayshawn is here. Meek is here. And then okay.
Can I ask a question?
Sure.
That's you only cancel out numerator and denominator, right?
Correct.
You never do like.
So the first one is a trick problem. Can I cancel the 5 from the 5 and the 10? No. I just multiply across the top and the bottom. And you can see there's nothing to reduce, right? 3 doesn't go into 50, so there we go. In the second one, I can reduce. I can have a 2 here and a 1 here. Can I reduce the green 2 and the black 2? No, because they're both on the same elevation. They're both on top. And that makes sense when we're done. There's nothing in common to 4 and 11 to reduce. We didn't miss anything. Okay, ready for the terrible one? I think this is my terrible one. 10 15ths times 6 eighths.
6 eighths?
Yeah.
And 15, and
So try that one a moment.
Oh, this was not
okay.
hard.
I'm going to make my 15 look a little more like a 15.
That was easy.
So the point of this one is that canceling again isn't some like magical virtue that helps you get into heaven. If you cancel some and multiply and still have to reduce because you didn't cancel everything that could be canceled, then that's fine. Just reduce at the end. There's nothing special about being a magic person who notices every possible canceling. So let's work together and try and notice everything. What's the first canceling we'll do? 6 and 15. So divide by 3, divide by 3. Okay. What's the next canceling we can do?
8 and 10.
8 and 10. So divide by 4, divide by 2, divide by 2. Okay, next canceling.
What is that? Oh, it's-
Just go straight across.
I could get 10 over
Like this.
20, go straight. But I have 2 5s, one on top, one on bottom. So they can cancel
Oh,
out.
you can do it that way.
Okay, one more. Yeah, 2 and a 4, divided by 2, divided by 2. So everything gets, does anyone ever do it this way? No. You probably don't cancel all 4 times and have to reduce your answer to get it to be 1/2, and that's fine. So But you could sort of go crazy with canceling if you wanted. Yes.
Now, when it comes to canceling, can you cancel other ways? Like, I know that the method that we're usually taught is just, cross diagonal, but could it be like top to bottom or left to right or?
They're all here, so let's look and see. The pink canceling was like a diagonal shape, right? It was one on top and one on bottom, which we need, and they're different fractions. The blue canceling, it was the same fraction, and that's fine. We're just reducing that fraction before we multiply instead of after. Right? 5/5, we can make it 1/1, and there's no problem. The orange canceling was also the same fraction. That's legitimate. It's okay. So as long as one number is on top and one number is on bottom, it doesn't matter which fractions they come from.
Would it have been just as easy to reduce each one?
We could reduce each fraction first and then multiply, sure. Okay, whoops. I said whole number and I meant mixed number.
So you just said 3 times.
I need to fix this in my notes. Whole number fix. So we're not writing things over one, we're having mixed numbers. So 2/3 times 1 4/8.
Do you just make it in
Was it really 4/8 I did?
some 8 plus 1 plus 1?
Yeah, I guess I did. That's a silly problem. I should change that. Anyway. So 8 times 1 is 8, plus 4 more is 12. So we can do some reducing. Oh, look. Divide by 3. We could divide by 4. We could divide by 2. We just get 1. Okay, any questions about multiplying fractions? So multiply top, multiply bottom, and any canceling you notice will make it just easier, less reducing at the end. Okay, if we're dividing fractions, remember we did that thing, ripping up papers, making piles of a fixed size. So think about that more if you're trying to figure out why this works. Again, the pictures are for people that want to know why the process works. So why is it we flip and divide, flip and multiply? That thing will help you understand that. But the rule is just flip the second fraction and multiply. It has to be the second. You can't flip the first one and get the right answer. Yes, reciprocal is the fancy math word for flipping a fraction over. So if I want to say 1/2 divided by 3/4,
So you just do
then the 1/2 stays the same. I flip and change to multiplying. Oh, look, some canceling. And I'm done.
Okay.
So that's not any harder really. One more step, but. Ready to do a few on your own? So, try 12, 13, 14, and 15, and then I'll do them on the board in just a moment. Whoops, and that should say by. I can't say and for divide. So for 12, the flip turns it into 10 over 1. I can cancel to save a little bit of time. And anything over 1 is just the whole number. For 13, I'll flip it and 2/3 becomes 3/2. I can say, oh,
These right?
you flip. And nothing is left there. Again, if you didn't cancel 4 times, that's fine. Hopefully you would reduce and get to 1. Anyone need more time on this slide before I switch to 14 and 15? Okay, any canceling in 15?
Not really.
Well, both of those 3s are on the denominator, right? So
Yeah.
I can't cancel because they're both in the same elevation.
What?
Okay, questions about any of these problems? Yes, Vince. I don't care. Math 20 doesn't care. If you are someone that goes to work in carpentry and baking, you like mixed number answers. If you're working in physics and computer programming, you like improper fractions. So I don't know what your career is, so either is fine.
What if you're a journalist?
If you're a journalist, they probably want mixed numbers. Not sure why. Any other questions? That was a good question. Okay, well, that was a lot. We did multiplying and dividing by fractions. The next thing we'll do is adding and subtracting them. So you've probably seen this before, and we have to have common denominators when adding them. Notice that we didn't before. So if we go to our pictures, actually, let me say that. So on this picture, I didn't have to think about 6 while I was actually doing my drawing. I just looked at the answer and I said, how big is that doubly shaded thing? Oh, that's 6. Similarly, in the next slide, I didn't need to think about 12s when shading and cutting. It was just at the very end when I said, oh, what did I actually shade? I shaded 6 of the 12. So it wasn't part of the process to deal with both. That's just me labeling my answer. That makes sense as a difference. For fraction addition, that doesn't work that way. So if I'm trying to put together half a cake and a quarter of a cake, then I have to actually deal with those denominators during my process. Let's see that happen with a shading that looks sort of like what we're doing here. We want to add a third and a half. So we have our third.
Are we doing with LCM? This 3.1?
Yeah, we'll need to find common denominators, and that's what we'll get to that phrase soon. So I have my third, and I want to add 1/2. So I'm still going to make my slice and start trying to shade in this half. And then I'm going to bump as I'm shading the top half. If I'm adding cake, I can't double shade. So maybe I can like steer down, right? Have this come down this way. But because when I'm adding, I can't double count something, then during the process of trying to shade in more, I have to think about 6 already. I don't wait till the answer. So maybe that helps you understand why we need common denominators for adding, but not for multiplying. Okay, we don't have much time, but let's go over this briefly with different cases, and then we'll do more on ACU 1.5. Sometimes one denominator is a multiple of the other. If I want to have 1/12 and 1/6, I can combine those just by making the smaller one into the bigger one. Whether I'm adding or subtracting. So that's a nice case. When one denominator is a multiple of the other, one is the factor of the bigger one, then I can make them match only by changing one of them. So that's great. Notice when that can happen and save yourself some time. So that's this part here. Sometimes there's no common factors. So if I have a 14th and a 15th, and I want to stick those together, then the only way to make them have the same number on the bottom is to multiply one by the other. I can say, let's do a times 15 there and a times 14 there. I'm not done yet, by the way. Now both denominators are 14 times 15. I don't know what that is off the top of my head, but whatever it is, they're going to do the same. That makes sense? Now, to be fair, I need to finish. If I do something to the bottom, I need to do it to the top. So that's our second case. I can look at these things, use our Lotus factors rules, and say there's no factors in common. This is 2 times 7, this is 3 times 5. So the best I can do is multiply each one by the other. It makes an ugly big number, but at least I know that this is the best I can do. And for the ones that get too bad, we're not going to have you do them without a calculator. The fancy name for that is relatively fine. 14 and 15 do have factors, but they don't have any factors they share. So I'm not going to use this phrase a lot, but if you want to write a sentence down when the two denominators are relatively prime, the best we can do is multiply each one by the other. Then the last case, the one that we'll actually spend some time thinking about, is, oops, let me make that. If they have some factors in common. So this isn't case 1. I can't turn 12 into 15, or I can't turn 15 into 12. Not that one is a multiple of the other, one is a factor of the other. Nor is it the second case, because they do have the 3 in common. So I want to be more efficient. Could I multiply the 12 by the 15 and the 15 by the 12? Sure, but there's a better thing to do. And we'll talk about that when I see you on Friday. So that's your heads up. Okay, we have 5 minutes, so you could pack up and run away, but I would take your turn-in homeworks. A bunch of you have had questions, I know, because you sent me lots of codes that were like 7 out of 10. So talk to your neighbors about those if you have a moment and get your codes all fixed up so that you can turn those in and get your nice credit. We did have questions on the fractions homework today, so it won't be due yet, but probably a week from Friday. At least fractions will be due, and maybe percents also.